So throw in robotics. You know,
Yes.
that's something I'm going to be going into is AI and robotics, just because I want to have the technology here to assist me on my little place, right? And it's a very intriguing technology for me because I can code and I understand how this sort of stuff works. But 5 years from now, we will be living in a world in which there is no labor market.
Would you actually have robotic servants at your house going around like
Oh, no,
taking
no, no. You
dogs
mean
for a
kind of
walk here?
replicate humans like Asimo and some of those? No, no, no,
Hmm.
no. No, no. By robotics and AI, I mean I'm going to have a smart greenhouse. It'll be able to adjust to the outdoor light levels and maintain the lights constant on my plants and that kind of thing. What people have a misunderstanding about artificial intelligence, okay? Because
Hmm.
artificial intelligence is really dumb. It's computer code being executed one segment at a time within assembly language, no matter how you cut it. That's all it is. There's no awareness of itself. It doesn't know what its next instruction it's going to execute or any of this. And so it's entirely driven that way. Plus, when they say deep learning, what they're talking about is letting a piece of software go and analyze other software. There's a fatal flaw in this, though. The people that are writing all this deep learning code, obviously, they need something to test their software against, right? And
Right.
so they will create a test bed, a sandbox, into which they will put what they think of as a representative sample of the real world that this AI is going to encounter. They will then let the AI loose and they'll tweak their neural network in terms of how it's absorbing the data and interacting with the other nodes in order to determine what it's actually learning. And then they'll get to some point where they say, we think that it's learned what it could have out of this sandbox. And then at some point they've validated this and they say, let it out in the real world. Well, the very first place that we've done this has been in the financial markets. And
Right.
the
With
AI is
algos that.
correct.
Mhm.
And algos have been involved, AI algos have been involved in trading opportunities now for probably close to 12 years, if you want to look at it one way, one particular way of tight AI that's under the control of a single corporation within their machinery and so on, right? And it's failing miserably. All right, it's lucky to get between 5 and 7% return on assets where their worst human analysts are getting 8 to 13.
But at the same time, it does push out the typical broker because they're not fast enough.
And the result of that has been the tremendous financial strain that these brokerage houses that used to provide a lot of analysis are under.
Right.
Here's what's going on. The software engineer says, okay, here's my sandbox that I'm going to build this AI against. And I'm going to build its AI deep learning routine against the 99,000 data elements that are within that sandbox. Now, this is something I personally, just as an aside, I know about. I deal in data sets that are in the hundreds of millions of records. So I deal in big data, okay? So I understand some of the pitfalls of this, but they engineer this stuff. And first off, their idea of mapping the real world conditions to a digital representation fails. It must fail. They cannot possibly replicate what that AI is going to encounter in a wide enough range within their sandbox that that AI would actually not stray out of that range in the real world. So it
So are
fails.
you talking about, like, say, we're looking at a brokerage house. Let's say I'm doing commodities like frozen concentrated orange juice. I look at weather patterns. I look at labor markets. You're saying AI may not be able to factor in all of these.
No, 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 no. I'm saying it's looking at all of that stuff, but where you have this intelligent filter, it simply has a vacuum. And the flaw in AI that is now proven, especially in financial markets, is that it is seeing stuff in the noise, calling it a pattern, acting on it as though that pattern is realistic, and causing other unintended side effects within its own operations that then snowballs off until that part of it has to be redirected back in. So AI's failures are showing up in the fact that they've got to hire more people to keep the AI reined in, and they're spending more time trying to keep it from seeing patterns in noise that really isn't there. And so when they want to have AI look at something and determine if a pattern is there, it's not like they take it out to a real world and say, look at this 1950s television signal and look at all of this noise and tell me if you can catch the 1 one signal we're going to allow to go through in some undetermined future from now. And if you do that, you find out the AI is going to find 200,000 signals to the one you let out, simply because your software engineers could not, in their minds, put in parameters that would screen out its ability to find patterns within the noise. And so AI has a very fatal flaw. I trust AI to run the lights at a street, right? I trust AI to make my dryer smarter, that it knows when there's less water in the clothes and it doesn't have to put as much heat in there. I would at some point trust AI to guide a surgeon in dealing with internal problems. Mm-hmm. Am I going to trust AI to do anything like policy, like direction, like guidance? No, I don't think so.
So it's kind of like Malcolm Gladwell wrote that book called Thin Slicing, or was about thin slicing, where they talked about like a very skilled human being, like an art curator, was able to just, their gut told them that this is a forgery. They couldn't like specifically say this, this, or this, but their gut, and they ended up being right. And we apply that. Skilled human beings seem to be able to apply that all the time.
We can't help it, okay? And it's because and they're actually trying. Intel has a project going where they've tried to redesign the computer chip. Instead of using what's known as the primary ring or the ring zero or the single point register approach that's been in domination all this time in computer chips and PCs, they're trying this thing that's like, it sort of replicates what goes on in our brains with our own little neural connections, right? And so these chips are amazing, but they're also only about 30 to 40% effective, and they're very expensive, and they're hard to program for, and so on. So there's levels of stuff that are going on within humans, that is to say consciousness. And so intuition can't be modeled, right? This kind of stuff. And this is something I know about because I used to write what was called expert systems under contract for people in Prolog, which was one of the first artificial intelligence languages out there. And it's really unique because it's a compiled, interpreted programming language, and can be used to alter itself as it's running. Very few programming languages can do that. And pure Prolog doesn't loop, it goes back and forth, and uses recursion, very much like the human mind does. So you can write some very interesting programs, but again, they're limited to what I could extract. So if I went to okay, so I worked for this thing called the Federal Base Expectancy Study. And the idea was that you could hand to a parole board a piece of software that would examine a man's life in and out of prison and tell you at that point if he was a good subject for parole. And so some analyst somewhere had come up with these rules, the AI, the algos that said, if murderer, better parole chance than car thief. Which is true, okay? Most murderers—
less chance of recidivism.
Correct. Most car thieves are back in right away. Most murderers stay out a little longer, right? And but there was only 325 elements that we had to extract from a person's life in order to model that person's life within the software. And so it was making decisions on 325 data points at a maximum, and many of those we never had. We went back to 1912. We analyzed all the prison records in the state of Washington from 1912 forward and tried to extract these 325 elements for each and every one of these prisoners. And I contend it was a very worthwhile effort, and it provided good intelligence to someone sitting there at a parole hearing to understand that you're talking to somebody that's likely to go back in because he was a car thief, he's a professional car thief, et cetera, and that the murderer you're talking to, it was a crime of passion, his brain was twisted, and it's likely not to happen again, that kind of thing, right? So so it makes for good intelligence, but would I allow a computer to sit there and accept the stuff coming from these people and then apply these 325 points to that? It doesn't make sense.
So what is, when you look at the future, because you've many times you've talked about, these technological revolutions that are coming, but then you also talk about space technologies, and then we also talk about woo-woo. Where are humans going? What's from inside us and what's coming from outside us? Where are we going?
We don't know since 1947 is my contention, okay? Prior to 1947, technology in